Today we're sitting in the Iziko Essay Museum in Cape Town, and it's a real privilege for us to have with us here today Roger Smith. Roger Smith is a paleontologist based at the museum, and he spent a lifetime working in the Permian and Triassic rocks of the Karoo Basin of South Africa. So Roger, it'll be really absolutely wonderful if you can try to summarize all this 30 years of work in a nutshell for us.
Well, thank you. I started back in 1976, in fact, looking for uranium, and it was at that time a strategic mineral that they needed to know which layers of rock they could find uranium in. And uranium had been found in the Karoo, but they wanted to find more. So I was sent out there first to do biostratigraphy, using the fossil vertebrates as an indication of which age the rocks were. So I could then tell them where the most likely place is to find more uranium. So that was the very first 3-year project. Okay. That introduced me then to the mammal-like reptiles, of course, therapsids that at that time were more than just animals to be used for biostratigraphy. I was getting more and more involved with how they lived and how they died and how those ecosystems changed through time. And I was looking at the late Permian period at that time, so working up through the late Permian, I saw the evolution taking place within the therapsids and the march towards mammalness, as they all call it. So, and I was intrigued then not just by how this was happening, but why it was happening. So I became much more, let's say, the question that I was asking was what drove the evolutionary transitions towards mammalness.
And could you see the paleo-environmental changes? I mean, was it very clear in the rocks that the environment was changing?
Yes, being a geologist as well as a paleontologist, I'm as much interested in reading the rocks as the fossils themselves. So my interest in the fossils sort of diminishes as soon as it's out of the rock. But seeing the fossils in the rocks, that of course gave me a lot of extra information about environments, about surface processes of these ancient floodplains, because it's all really floodplain deposits, and how those floodplains were getting wetter and getting drier, and the processes that led to the actual fossilization of the bones that were lying around on the surface. So that's taphonomy, which is what I specialized in at that time.
Do we see between the Permian and the Triassic, are there changes that we can find within the rocks? And does that help us then say something about what happened at the end of the Permian?
Yes. This, of course, so it wasn't long before I got up to that very dramatic change in the rock record. Yes. That in the Karoo Basin especially, it manifests itself as a distinct drying of the environment. So the rocks in the late Permian are predominantly blue-grey and contain these big lumbering herbivorous mammal-like reptiles. And suddenly there's a rapid transition over about 5 meters into predominantly red and maroon colored rocks. The reason for that happening after much research appears to be a drying out of the floodplains. The water tables dropped and it caused then the vegetation to die off. The floodplains became barren and exposed and oxidized. So the reddening is caused by the oxidation of iron in the soils, in the sort of tropical soils, if you like, of the earliest Triassic. And coincident with that, of course, was a rapid change in the fauna. In fact, an extinction of many of the Permian herbivores and the carnivores, and then the arrival very soon after of new forms, especially the archosauromorphs, which were these sort of very first indications of dinosaurs in the Karoo Basin.
Yeah, that's fabulous. Yeah. And what I'm wondering about is, when we look at the late Permian, we see there's a drying out. And in terms of the fossils themselves, do you find kind of aggregates of fossils together? Is that something that's common in the landscape? Maybe around waterholes or things like that?
During this great drought event, we do find aggregations of juveniles in much more open, shallow depressions, which is interpreted as dried up waterholes, or that the juveniles were huddling into a depression, perhaps at times in cold snaps. But definitely the bone beds as such, where there was multiple animals, all of the same taxon, all the same animal, all the same type of animal, all aggregated into the same place, happens a lot more in that early Triassic drought period than it does in the late Permian.
So what is your pet hypothesis about why there was the end of the Permian extinction event?
My pet hypothesis is drought on land. That is and we have been able with a lot of paleomagnetism and radiometric dating now to make sure that the on-land and the marine extinctions were synchronous at the same time. So we're pretty sure then that it is a global effect, and we are recording in the Karoo Basin a great drought at the very safe cell time that in the marine realm they were recording acidification and deoxygenation of the marine realm, caused almost certainly by a rapid increase in atmospheric temperature globally. The most likely cause is volcanism. Massive outpourings of basaltic lava in the northern Pangean area in what's now the Russian, northern Russia.
Roger, thank you very much for talking to us. It's been absolutely fabulous to hear about your research, and we wish you well in your further research that you are doing. So thank you.
It's a pleasure.